Have you ever looked up at the sun and wondered how that giant ball of fire keeps burning? It's not a normal fire like we have on Earth. It's something much, much more powerful. The sun's energy comes from a process called nuclear fusion, and it's happening right now, 93 million miles away. Let's travel to the very heart of the sun. The core is an unimaginable place. The temperature is a staggering 15 million degrees Celsius, and the pressure is so intense it crushes atoms together. It's here, in this cosmic furnace, that the magic happens. The most common element in the universe, hydrogen, is being squeezed with unbelievable force. So, what is nuclear fusion? Think of it like a cosmic recipe. You take 4 hydrogen atoms, or more specifically, their nuclei, and you smash them together. Under the extreme heat and pressure in the sun's core, these hydrogen nuclei fuse to create one new, slightly heavier element, helium. But here's the incredible part. When those 4 hydrogen nuclei combine to form one helium nucleus, the final helium nucleus weighs just a tiny bit less than the 4 original hydrogen nuclei combined. A small amount of mass seems to have vanished. But it hasn't vanished at all. It's been converted into a tremendous amount of energy. This is where Albert Einstein's famous equation, E equals mc squared, comes into play. E is energy, m is the lost mass, and c is the speed of light, a huge number. This equation tells us that even a tiny amount of mass can be converted into a massive burst of energy, and the sun does this on an unimaginable scale. Every single second, the sun fuses about 600 million tons of hydrogen into helium. In that same second, about 4 million tons of its mass are converted directly into pure energy. This energy, in the form of light and heat, radiates out from the core. It takes hundreds of thousands of years for this energy to travel from the core to the sun's surface, and then just over 8 minutes to journey across space and reach us here on Earth. So, just how powerful is the sun? The total energy it pumps out every second is about 380 watts. That's a 38 followed by 25 zeros. To put that into perspective, it's trillions upon trillions of times more powerful than all the energy humanity uses in an entire year. It's a number so large it's hard for our brains to even comprehend it. And yet, Earth receives only a tiny, minuscule fraction of this total energy, about 1/2 billionth of it. But even that tiny sliver is enough to power our entire planet. It drives our climate systems, creates our weather, warms our oceans, and fuels the process of photosynthesis, which is the foundation of almost all life. From the smallest blade of grass to the largest whale, everything is powered by the sun. Without the sun, our planet would be a dark, frozen, and lifeless rock. There would be no light, no heat, no plants to produce oxygen, and eventually no atmosphere. The sun isn't just a bright star in our sky. It is the engine of life, the powerhouse that makes everything on Earth possible. So, how long will our star keep shining? The sun is about 4.6 billion years old, roughly middle-aged for a star of its type. Scientists estimate it has enough hydrogen fuel in its core to keep burning like it is now for another 5 billion years. Eventually, it will run out of hydrogen, swell up into a red giant, and its life as we know it will end. But for now, we can rest easy, knowing our star will continue to power our world for billions of years to come. It's a constant, reliable source of energy that we owe our very existence to. Thanks for watching. If you enjoyed this journey to the heart of our star, don't forget to like this video and subscribe for more cosmic adventures. See you next time.